Hello and welcome to another edition of Deep Dive Sessions. I'm Chris Clausing, Program Director at Gold Coast Schools, and we're here with Dan Villa, our
Hello.
plan reading
Hi.
guru. How are you, sir?
I'm good.
All right, excellent,
Thank
excellent.
you.
So we are taking another deep dive into the Module 10 plan set. So this is what we'll see in your General Contractor Study Manual, Module 10. You'll see this plan set along with a couple others, but we're going to focus on this particular one.
Right. And we're going to do some area takeoffs.
Yes, area, volume.
Yeah.
It's going to be very, very math oriented. So this is stuff that you will most likely see on the state exam. So you want to, we're going to kind of go through this very simply and then work our way into a little more complicated
Yeah.
scenarios. All right. Perfect. So I'm going to, I'm going to jump in on this. Let me show you the plan set. So this is the, we did a deep dive sessions video on site plan. So if you go to deep dive sessions site plan, you'll see your review of this particular site plan.
Yeah. But we're going to orient ourselves real quick here for this question, right?
Yeah, go for it. Can you show us where we're going to be looking
All right.
on this one?
So we are going to be calculating the area of, in square feet,
There you go.
of sodded area number 2. Okay. So we're going to be over here on this side of the plan.
Perfect.
All right. Okay. So remember when we're looking at site plans, but any plan, we're going to be looking for our notes. Okay. So sodded area 2, we got a note here with a little arrow thingy, kind of boop, 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 boop.
Yep.
Right. And it goes all the way from here to here, right? So sodded area 2. So we're going to be looking at this part here, which is a triangle. Okay. And this part here, which is a sort of a portion of a circle, right?
There you go. Yeah. So kind of a weird shapes,
Yeah.
a little complicated when you look at it, but it's actually pretty simple.
Yeah, you just got to break it down.
Got to break it down. So let's do it. Let's break it down here.
Okay, let's break it down.
So I'm going to show you. We're actually going to be utilizing my fun new toy, my light board. So we're going to be utilizing that. We're also going to be. I'm going to be showing you how to do this with. Let me see here with our calculator. All right. So this is our Construction Master Pro calculator, which will be able to be using this as well. So I'll be popping this kind of up and down as we go through. But let's start with the basics of, let me make this a little bigger. So let's start with the basics of kind of general area calculations, right? So the first calculation that we need to kind of consider is going to be, I'm just going to start with very, very simply, a square.
Okay.
All right, so let's say we have a square, right? And we want to find the area of this square. This is 10 feet, and this is 10 feet, right? So since anything with area, no matter what it is going to be some dimension times some other dimension times 2 dimensions. In this case, maybe a length times a width. Could be any dimension. As long as there's 2, you're going to be set there. So you have area, length times width. So in this case, your area is going to be 10 feet by 10 feet, right?
Right.
So we have 100 square feet. Very simple.
So this is linear dimension times linear dimension equals area.
That's it. So that's kind of the basic start, right?
Yeah.
Now let's take this same shape and let's divide this kind of in half like this. All right. Well, so what do we have now? We went from a square to what?
2 triangles.
2 triangles.
Yeah.
So we have basically 2 triangles here. So the area then of a triangle must be my length times my width divided by 2.
Yeah.
But in terminology that they use for this is they actually call this, let's call the 10 feet here, they call this a base, right? And they call this 10 a height.
Yeah.
Or a height. So really what you'll see, this formula referred to as base times height divided by 2.
Right. That makes sense. So you just have 2, right?
Now you have 2, right? So now you have 2 triangles, but the area of this triangle, and then you have the area of this triangle. These 2 added together, obviously, is the area of your square.
So you can, and this goes the other way too, right? Now Chris is just showing starting as a square, But if you just have a triangle, you know that you can like here. Can I?
Yeah, go ahead.
Can
Yeah. You're ready.
This
There
is
you go.
this is fun.
Yeah. See, this is so cool, right?
Yeah. Okay. So let's say we have a triangle, right? We have to imagine that it's a square, right? So you
Right.
kind of like just sort of extrapolate, right? Just extrapolate that into a square.
There you go.
Because a lot of times, like if it's asking us for the area of a square, that's easy, 10 by 10. But if it's asking us for the area of a triangle, we gotta imagine it's a square first before we can get the triangle area.
Right. Yes, especially if you're trying to just figure out the formula for it. So this is a good way. I always think of, if you just think of it, because most of us are very similar or very familiar with squares and rectangular shapes. So, we take an irregular shape and we turn it into a regular shape. You're going to see that theme kind of throughout this video. Okay.
Yeah.
So that's kind of step one.
Right, and the reason I mention that is because when we look at our plans here, right, our site plan here, we got two shapes,
Right.
right?
Yeah. You got the triangle here.
Yeah,
Right. So
here.
so now we kind of figured that piece out.
This is our triangle.
We'll go through the math of it, but at least we kind of know, okay, we have a triangle. We know how to,
We're conceptualizing it.
how to calculate this.
Sounds fancy.
It is very, that is like, come on, we gotta cut the word shorter. That's crazy. This is, you can look at this shape now, right?
Mm-hmm.
And so again, we have an irregular shape, but I want to make this a regular shape. So really what I see here is not this quarter donut shape. I see two full circles here.
Absolutely.
Well, you know what I mean?
two quarters of a circle, but yeah.
Yeah, I see two quarters, but if I make it like the whole circle, like a small circle and a big circle, right? That's pretty straightforward. We could calculate.
I'm going to draw that so we can
draw
kind of
that
see
out,
that a
yeah.
little bit better here. So we have here our, we just have these two arcs, right?
Yep. Mm-hmm.
And so I'm going to go ahead and imagine, okay, this is a center
Yep.
of the circle. So we got one here.
There you go.
Let's see my circle drawing.
Perfect.
That's terrible, but okay.
That's actually pretty
Freehand.
good. Yeah, that is
all
not
right.
bad for free.
And then the second one is like that.
There you go. So
Okay.
so I see two
Yeah.
circles there,
We got
right?
a donut.
Yeah. And so
We got to take the hole out of the donut.
exactly. We got to take the whole out, and then we got to take 3/4 of it out,
Well, yeah,
right?
we gotta
At
eat
the end of it.
3/4
We got
of
to
it.
eat 3/4 of it. So all that to say this, we do have a formula for that. It's very simple.
Yeah.
All right. I'm gonna show you that, and then a kind of a trick on the calculator to do
We
that.
should have brought donuts.
We should have. Well, I know you would have eaten them. I wouldn't have gotten a quarter of it. I would have gotten 0. So let's see. Oh, the donuts do sound good.
Okay.
All right, let's go back to the board. Okay, so we can do this the old-fashioned way. We're going to do it kind of the cheat way. All right. So the old-fashioned way. So an area of a circle. Okay. So an area of a circle is going to be pi times r, which is the radius, times itself squared. This is the area of a circle. Okay.
Okay. Yeah. I'm going to write that here.
Yeah.
You go ahead.
Okay, so pi is valued, the general value of it, 3.14. Okay, when we use the calculator, you don't need to memorize this. Calculator knows what pi is. And kind of where pi comes from, just as an aside, so if I have a circle, so if I'm dealing with a unit circle is where I have 1 foot, all right, or 1 mile, or 1
Any
inch,
length.
any length, one
Yeah.
unit of any length. If this is 1, the diameter, right? So we know the radius is half, right, from this point to here, but the whole distance from arc to arc, that's the diameter. But that's where pi comes from. If I have a unit circle of a diameter of 1, that means that if I start at this point and I roll this circle all the way around 1 revolution, till I get back to this point,
Yeah.
I'm going to have traveled 3.14 feet.
Yeah. Okay. And that's always, it's a constant.
It's always a constant, yeah. And
Yeah.
so you see pi, you see this number pop up in math all over the place, but that's kind of how they discovered it was, okay, if I have this unit 1 here, this is always coming back at 3.14.
Yeah. It's just kind of math.
Just kind of math. That's it.
Yeah.
So that's kind of where pi comes from. It's a ratio of the circumference and the diameter of a circle. So there we go. That's not going to be on the test. You know.
No, but it's good to.
It's good to know.
It's you know, I think part of the reason why we're doing these deep dives is just so you can get in, well, like a little bit past the surface. You know what I mean, of these things. So I think that's great.
Well, and like I said, we're going to show you the shortcut too, which is great. But it's good to know a little bit of the history. So then you're going to take the radius, which we know is half the diameter, right? So really, another way to say radius squared is radius times radius. So the radius times itself.
Yeah.
Right?
Remember, it's not radius times 2.
Exactly.
It's radius squared, which is radius times radius.
There we go. There we go.
Yeah.
Very good point. Now, the other thing with circles, so we have the area of a circle, which is great, but we can also calculate something called the circumference. Circumference of a circle, and that one is 2 times pi times the radius.
Okay.
Okay. So another word for circumference, you wouldn't use circumference in construction, you would use perimeter.
Right.
And this might be if we're trying to calculate the length of some circular object for maybe like a curb, or we need the landscaping. We need to landscape a curved area. You could determine the perimeter by using the circumference formula.
Yeah, and just like when we zoom back into the site plan there, you can see that curved area, it has a curb
Right.
on the parking side. So they might ask you, what's the length of that curb? You're going to use the circumference equation.
Exactly.
But we're not going to do that today.
Yeah, we're not going to do the lineal. We'll do the lineal footage on another one.
Yeah.
Because we'll just do perimeters and lineal footage maybe for when we do the concrete walkways. We might be able to do the curving. Okay, so that's kind of the longer manual way, which is totally fine and acceptable and great. But also we have some features of the calculator here. Let me just pull that up. So again, we just kind of get you familiar. This is the Construction Master Pro.
Yeah.
So this is the one that is allowed into the test.
Yeah.
For the business finance, I would recommend just taking in a simple calculator for the business finance. You don't really need this calculator for business finance. This one's more for the trade exams. So this is we sell this at Gold Coast, and you can also get this at one of our campuses, or you can buy this off in the bookstore. We can ship it to you as well.
Great.
But it's a great calculator, and it's one that I use. So when I do the weekend workshops, so those who are enrolled in the pre-licensing courses, we do weekend workshops, and I train basically the morning of the Saturday session. I do about an hour and a half of this calculator.
Oh, great.
So yeah, it's really a good session. And okay, so let's take the area of the circle first. We have right here, you see where it says circle. I'm going to kind of give you the layout of this calculator. So you have circle here.
Yeah.
You have this orange convert button here. And then you'll see above, like a lot of these, you'll see letters in orange and letters in dark gray. Okay, so any letter in orange, it's a little. Let's make this a little bigger.
Yeah.
There we go. Okay.
Oh, there we go.
Well, I think it's cutting it off.
Hang on. Sorry, you're gonna see like a behind the scenes here.
Yeah, you go. Oh, you have the actual one.
I'm gonna follow along.
Oh, there we go. Yeah. Mine. He stole that.
IRL.
So we have. So we're going to just focus on the circle, but in the future videos as we do stuff, I'll go through all these at some point, but we'll just focus on the circle one.
And this is super useful in real life.
Very much so. Yeah, this is a great calculator. So let's just assume we had a circle with a radius of 10 feet.
Yeah.
So we're going to start with this circle. We're going to have a radius, which is the middle, and we're just going to say that the radius here is 10 feet. Okay, that's going to be our starting point. So in that case, what we would do is, I'm going to show you the long way to do this and then the shortcut way to do it on the calculator.
Okay.
So we're going to take 10
Yeah.
feet. You always have to enter the units of measure that you're, whatever they give you. So it's feet or inches or yards or whatever the unit is. So in this case, it's feet.
Okay.
And then we're also going to push convert, and then above this arc button in orange, it says radius. We're telling the calculator that we're entering in a 10-foot radius there. Okay. Once we click that, we're going to click circle, and the calculator is going to tell me, okay, then you have a 20-foot diameter. Is that correct? Which it is. Totally correct. So we know we have entered this correctly, because if we have a 10-foot radius, its diameter is always double that. Then you're just going to click circle again, and it gives you the area
Oh, great.
of that circle. So again, remember, the unit circle was a 1.
Yeah.
It could be 10. So 1 was 3.14. Now that it's 10, look at what the area is, right?
Yeah.
So you see that pi in that area, it's all the same. And if you go here, let's go here, then you've got a circumference,
Yeah.
right, of 62 feet and 10 inches. Okay.
So how did we get that one?
So this one, you just keep clicking circle.
Oh, okay. So you're just basically clicking through, and it just keeps telling you the info
There you go.
that you're looking for.
There you go.
Yeah.
Perfect.
Okay.
Yep. So you just keep toggling through. Now we don't really care about circumference on this particular video, but that's what that would tell you, is that a whole perimeter of that circle would be 62 feet 10 inches.
Nice. Okay.
All right. But we care more about just this, right? So okay. Now let's go back to the plan,
Okay.
and I'm going to erase this.
You want me to drive the computer?
Yeah, will you?
Yeah,
Just,
sure.
just
Yeah, while you-
scroll it over there, and let's get. Oh, perfect. Okay, so just so they can see, so we have two circles, right? We have our smaller circle, right, and we have our bigger circle.
Mm-hmm.
We still have the same
Yeah.
midpoint.
Smaller here. This one. Larger here.
There you go. And then it gives you the radiuses, right? So for the small, the radius was 90 feet, right?
Yeah, that's right. 90 feet radius.
And for
Just so y'all know, right? When you see rad on a drawing, it stands for radius.
there we go.
Does not stand for cool.
It is, but it is cool. It is super cool, but it does not stand for that.
Okay.
All
All
right.
right. So we have those two radiuses, small and big, 90 and 120. We got that?
Yes.
Ready to?
Yeah,
zoom
let's
back
scroll
out?
back. Okay, I love that little. That's so neat. That scroll thing. Okay,
Okay.
I'm easily
Construction
impressed. Here.
calculator.
Yep. So we'll just do a left,
There it
left,
was.
left,
Got it.
left. There you
Boom.
go.
Got
All
it.
right.
Okay.
Let me grab
Yeah,
the
sure.
joystick here. Okay, so we have a small radius of 90 and a big radius of 120.
Yeah.
So you'll see this also when we do calculation of volume of, let's say, those planters or the elevator pit, which is future videos. We're going to do this thing that I call, we're going to take the big area and we're going to subtract out the small area, and what's left will be kind of your answer, the area that you care about,
Yeah.
right?
So we're taking the small area, subtracting it from the big area.
There you
Big
go.
minus small.
There you go. Because your big area is going to include, right, everything.
Mm-hmm.
And then you take the area of the small, we take that out, and what are you left with? You're just left with this big donut shape, right?
Yeah.
And then what we're going to want to do, since we're only dealing with a quarter of this, we're only dealing with this donut shape, right? We're going to have to take whatever answer we get for the donut, and we're going to have to divide it by 4.
Okay.
All right? That's going to be the general process.
All right. So we're going to divide it. So just so I'm clear.
Yep.
So it's 4 parts, right? 4 equal parts, and
Yep.
that's why we're dividing by 4.
That's why we're going to divide it by 4.
Yeah.
Exactly. So if you'll draw me a new circle there. Or a
Well,
new-
let me erase.
yeah, race, and then
Everything, or you
just
want
we'll keep the small and the big
Yeah.
numbers. There we go. Yeah, and you're so much better at drawing than me. So give me my 2 circles again.
It's my passion.
It is. Oh, you probably need that. All right.
Okay.
Perfect. So actually, we'll start with the 9. Let's start with the small one.
Okay.
Let's start with this one. So we know we have a radius of 90. So I promised that I'd show you a shortcut to that instead of entering the radius. Well, if we know the radius is 90 there, what's the
sorry.
diameter have to be?
Yeah.
Double that, right?
Are you asking me? It's
Well,
180.
yeah.
Yeah.
180.
Well,
Well, I know you.
right, yeah. It's the diameter is twice. It's 2 times the radius.
2 times
it's
the
always
radius.
just radius times 2 is diameter.
Exactly. So we have 90. So I'm just going to enter 180 feet. Now look, if I just click circle, I bypass that step. I haven't entered the radius here.
Love it.
I can just enter the diameter, right? So it saves me a step. It actually saves me a couple of keystrokes there. I just click circle again. There we go. We have 25. I'm going to round because I hate these numbers. I'm just going to round to 25,450. Let's write that on the area of the small is going to be the 25,450.
Okay, I'll put it here. You can see it
Yeah.
on my shirt, right?
Yeah, there we go. We got you. You're wearing the
Okay,
right
so
color.
area equals 25, 450.
Oh, you went off. Look at that. You just went off. You went off the res. Look at that right there.
Sorry.
It's okay. See?
You can edit that
See,
out.
he's Yeah. Oh, we keep everything in here. We keep everything in this.
All right, so 25, 450.
Perfect. Okay, that's the area of the small, right? Now let's take the area of the big. We know we're at 120 radius, so we're going to enter 240 and feet, and we're just going to go circle again because that's the diameter. And then now we have. I'm gonna cheat on this too, and 45 240. You don't have to be exact on these big area calculations, so make your life easy. Now we got to take the difference of these two. So 45 240 minus 25 450 gives you 19,790. So let's just write that right there.
19,790.
Yeah, 19,790. And then we'll just do our other big circle just so we can illustrate what we're doing. So
Right.
we have basically calculated the area of that donut, have we not? So this donut shape now here is 19,790. So what do we have to do now? We got to divide this
Divide by 4.
There we go.
Okay,
So
so,
we're gonna
yeah,
divide
we're
by
just
4.
going to get, we just want in the plan basically like this, right?
That's it. So we're going to divide that by 4, and we end up with 49. We'll call it 4950.
Okay, so we're taking this here, divide
Yep.
by 4,
There you go.
and that equals, sorry, I know I'm a little bit off the screen.
That's
there.
okay.
Ooh, yeah, okay. So this guy here, what is this?
That we'll just call it
49.
4950. We don't have to be exact. I mean, it's 49, 47.5, but we're talking about thousands of square feet,
Square
so
feet?
it's okay. Yeah, this is gonna. And that's a square foot measure. That's a very important thing. It's a square foot measurement, right? So this
Right.
is an area measurement, 2 dimensions here.
Yeah, so we're starting with linear here, right?
Yep.
And going to square feet.
That's it. That's it.
So this is area.
Now the other shape that we need to look at. And I'm just going to minimize the calculator for a second. I'm going to bring your plan back. Is we got to deal with this triangle now,
Yeah.
right? So let's go to the triangle real quick.
Oh, yeah, sorry.
And let's show them
Okay.
what we're dealing with here. Okay, so we have, go down just a little bit more. I want to see the dimension line at the top. There we go. The 31
here we
feet
go.
6, right?
Yeah.
So this 31 feet 6, they kind of give us one of the dimensions, the base,
Mhm.
which is great.
Yeah.
So we have the base already here. What we're missing here is the height. Now they give us the dimension line here and here, right? As 170 feet.
Right, but that's not that's not to the triangle.
Right. That's not telling us what we need, but it's giving us something. It's telling us it's giving us some bit of information here, but this is an example of when we're going to have to use other dimensions on the plan to find a missing dimension.
Right.
That
Right,
doesn't,
right, right.
that's not there, right? So what I do, if you zoom out on that plan a little bit, there's multiple ways to do this. And again, I like to just round things. I know I'm architect's worst nightmare. So, but for these types of big, large areas, you know what? Let's make life easy.
Yep.
So we need to find we know the dimension from the tip of this triangle to the property line is the 170. So we got to figure out, okay, well, what's the distance from the top of the property line to the top of my triangle here?
Yeah, exactly. So basically, we want, if I were to draw a dimension string, we need this dimension.
There you go. We need to kind of find that. So what I do is I go some other parts of the plan to figure out, well, I kind of know that my distance from the property line to, let's say, the building, pretty clearly 42 feet here. This
Yeah,
dimension.
yeah. So right, we're just like looking at the top of the triangle and keep sort of like looking over to the left until you find some dimensions, right?
Right, that are kind of closer in the ballpark. 42 kind of works for me. Now there is some additional, I mean, if you want to get really, really crazy with it, the 42 feet plus this 7'6", but this 7'6" already includes this 2 foot, I think that's 8
Yeah.
there. So I don't know, you could say basically what, 5 feet more or less?
Yeah. So let's take 7'6", subtract 2'8".
Yep.
You get pretty close to 5 feet.
Yeah, and then you just add that to the 42 feet.
All right.
Right?
I'm gonna write that here.
Yeah,
so
yeah,
that
go
we
ahead.
Can, yeah, and we're done.
We're done with
this.
that. Yeah, you can do
So-
just keep the 4950 is good.
Yeah. So you gotta. Boy,
You love
get,
this board.
getting like an arm
You love
workout.
this. You really do.
Okay.
You-
And so this is our arc, right? Arc area.
Yep.
Here, just so we can remember that. Okay. So what are our dimensions here? 170.
Yep. So we have 170.
Uh huh.
We have minus 42.
Mm-hmm.
And then we have to subtract out that 5 feet as well
Mm-hmm.
that we kind of
That's
extrapolated.
Okay.
So
Is that it?
That should be it.
Yeah.
So let's go to the calculator here, and
Sure.
we'll use it. 170
Mm-hmm.
minus 42 minus 5. So we end up with 123. Perfect.
Okay, so 123 feet. So this dimension is here on my dimension string, right? 123.
There we go. And we have our base. So that's basically our height, right? And this is our base is 31. There we go. And our base 31 feet and what is it? 31 feet 6 inches. So we'll add 6 inches to it. We can do it in the calculator very easily.
Oh yeah, I got cut off there. Sorry.
That's all good.
Well,
You're fine. We'll
okay.
add it on the calculator. Oh, so let me do this. Let me zoom back out just so we can see the drawing a little better. Oh yeah, you did get cut off. It's okay.
Yeah. Well, let me write it again.
Okay, right.
Phase. Yeah, I heard like, oh, no problem. 31 feet, 6 inches, and then height.
Perfect. All right, so now we're going to use the calculator, and we will do our calculation here. So remember, it's
Wait,
base.
what are we doing?
Well, we're trying to calculate the area of that triangle.
The triangle. Okay.
Right. So area is base times height divided by 2.
Mm-hmm.
Right.
Sorry, I need undo. This
Undo.
thing needs undo.
This is very unforgiving. This board. There it is.
There we go.
Perfect.
Okay, so 31 feet, 6 inches.
There it is.
And we ended up with
123, right? Yeah, for the perfect. So we're going to do base times height divided by 2.
Yeah.
So
remember,
we
remember, we're going to imagine that as a
there we
rectangle.
go. That's exactly right. So let's do. It doesn't matter which way you do it either. Multiplication is commutative, so it does not matter. You can multiply in either way.
Mm-hmm.
So we'll take 31 feet. You have to enter it the way you would say it. 6 inches.
Yeah, don't forget the feet and inches on there.
There you go. You have to have the dimensions, right? Or the units of measure. Times 123 feet equals, so that would be the area of a rectangle,
Mm-hmm.
right? But now we got to divide this in half. Divided by 2.
Mm-hmm.
Let's call this 1940. Oh,
All
that's a
right.
nice round number.
Okay, so what I'm gonna do is actually erase this side. We got our good triangle stuff here.
Yep.
So here's our arc area. So, and then our triangle area. Okay. Equals. What is it again?
And it was, I knew you were going to ask me.
Sorry.
That's why I saved it. Let's go 1940. Just around.
1,940 square feet.
Square feet, right? So now we're just going to take the difference. We're going to add, the difference.
Yeah.
See,
you want to
contractor mistake. Now we got to add these together, right? Because we want the area of that little quarter-shaped donut, and we want the area of the triangle. So now we've calculated them both independently. We got to add them together. So we have 4950.
Mm-hmm.
I'm going to go ahead and just put square feet because I want to, and I'm going to put feet. That you're telling the calculator now it's square feet.
You click on it twice.
Click on it twice, and if you want cubic feet, click on it a third time.
Okay.
Okay, we're not doing cubic feet today, but
Yeah,
and you can just toggle it too. We're going to do square feet. And we're going to add in the 1940, 40 feet. So we have square feet.
Yep.
So we have 6890 square feet. But so we can kind of write that down. We'll write 6890.
Okay.
Sometimes they're not going to ask you for this measurement in square feet. They're going to ask you for this measurement in acres. So I want to show you that.
But if
feature.
it's asking for square feet, this is it.
That's it. Yeah, if it's asking for square feet,
You just
done.
got to be very careful during the test and make sure you're paying attention to the units.
Exactly. You have to pay attention to the units. So in square feet, you're good. If it's acres, then if you see above the number 2, you have that orange acre button. You just push convert to, and there you go. You have just under 0.16 acres.
That's great.
It converts the acres for you.
So sodded area 2. Let me write down 8 acres here. So 0.158 acres. How many square feet are in an acre, Chris?
Well, it's funny you should ask. So if I have 1
You don't know?
acre, And
I think it's wait. Let me see. It's
go for it.
43,560.
Look at that.
Ah,
Perfect.
You know the trick?
Tell me the trick. I remember. I thought I remember, but I
Okay,
don't.
7-Eleven.
Okay.
You got to remember the 7-Eleven.
Okay.
The convenience store, because you take 4 plus 3 equals 7.
Yeah.
5 plus 6 equals 11.
Oh, okay. Plus a donut.
Sure.
Which right? Which ties in our whole thing. Oh my gosh, this is so good.
Yeah.
All right. Well, there we go. We did
All right.
we did the sodded area number 2.
Hey, let's look at solid area number 2 just real quick there
Yeah.
before we sign off. So
Let's
that
take a look at
is.
it. Do you want to erase? Do you want to erase your beautiful artwork first?
Yeah, whatever.
You
I
good?
don't want to
Okay.
see my face. Okay. Yeah. So remember, solid area 2 right here is it's both areas combined into one.
There we go.
Right.
There we go. We have another. So we have a bunch of these deep dive sessions.
Absolutely.
So go to the next video, and we're gonna dig into another section of the Module 10 plan set. That was
Cool.
awesome. Thank you, sir.
Thanks, man.
Always a pleasure.
See you soon.
Yep. Thank you, guys. We'll see you on the next one. Have a good one. Bye.